Here we're using synthetic division to find all of our roots of a polynomial. So if you recall, before we used synthetic division, we did factoring to find our roots. So we had to factor things out to figure out where those x-intercepts are. So if you can see here, I have 1, 2, 3, 4 terms, and I'm going to use synthetic division to figure this out. Okay, so just looking at this, we can figure out what our possible rational roots are. So we do this by doing plus and minus of the p over q, all the factors of p over the factors of q. So 5 is going to be my p, and 5 is my q. Okay, so factors, so thinking of our factors, they're both 5. So factors of 5 would be 1 and 5. So when we think of our fractions, we have to do all factors of the top and all factors of the bottom. So plus or minus, we'll do, I like to do a denominator of 1 first for my factors of the q. So over 1, so 1 over 1 is 1, and then 5 over 1 is 5. And then with a denominator of 5, I would have 1 over 5, and then 5 over 5, which is just 1. So those would be all my factors. Okay, so with the synthetic division, I like to start with 1 first because 1 is the easiest to use. So we have to test these out to see which of these are factors of the polynomial. So I'll start with positive 1 and then put my coefficients. So it'll be 5, 29, 19, and negative 5. So 3, 2, 1, constant. So I don't need any placeholders. Bring down the first term and then just do your synthetic division. So as I can see, 53, looking at the end here, I don't even need to add these together to know this won't come out to be 0. So 1 is not a factor. So let's try negative 1. Okay, do our synthetic division. And here we have negative 5 times negative 1 is 5, and this comes out to be 0. So this one is a factor. We'll put a little check sign next to that. That is definitely a factor, negative 1. So if negative 1 is a factor, we would be left with this expression. Now we have a couple options here. We can either continue doing synthetic division with what I have left, which that would take a while, or we could just factor what we have. So this is x to the third. So after you do the division once, we decrease the exponent by 1. So this is x to the third I'm starting with, and it's in, we have all of our terms. So this would be x squared. So pretty much what we have here, we have x is equal to negative 1. So that's one of our factors. And then I'm going to write out this 5x squared plus 24x minus 5. Okay, so my highest exponent was 3 to start with. After division, I decrease the exponent by 1, and it's in decreasing order. So 5x squared, 2x to the first, 24x to the first, and then minus 5 is my constant. And then we just have to remember how to factor 3 terms. So factoring 3 terms is when we do the a times c, and then the b term goes on the bottom. So two numbers that would multiply to be negative 25 and add to be 24 would be 25 and negative 1. Okay, so from here you can do the box or the grouping method. I'll just do the box over here. And then 5x squared goes in the top left, negative 5 bottom right, and then these two go in the diagonal, so I have 25x and negative 1x. So my GC up here is negative 1, GC up here is 5x. Here I should have x, and here it would be 5. So we have 5x minus 1, x plus 5 for our other factors. And then we just need to solve because we're trying to find all the roots. And all the roots is where x is equal to. So 5x minus 1 equals 0. We would add 1 and then divide by 5 to get 1/5. X plus 5 equals 0. Just subtract 5 to get x equals -5. Okay. So that's the first one. Let's look at the next one. It's very similar to the first one with your factors being 3. And actually the whole process will be very similar to this first one. So for your possible roots, we should have, since it's just 3 and 1, 3 is a prime number, we would have plus and minus 1, plus and minus 3, and plus and minus 1 over 3. So if we try this again with 1, we'll have 3, 11, 5, -3. 3 times 1, 14, 19, 19 times 1. So this one's not going to work out. Let's try -1. Bring down the first term. -3, 8 times -1. Add -3 times 1 is 3. So this one is a factor. We have a remainder of 0, so that means it is a factor. So x equals -1. Just don't forget to include that in your answers. After you do this synthetic division, make sure you note that this -1 is one of your answers. Okay, so looking back at this one, remember our highest exponent says how many answers we should have. We should have 3 here, and we do have 3. So here's our first answer, x equals -1. And now I'm going to put this with my variables. It'll be one lower of an exponent. So this x to the third, so this will be 3x squared. And we have 3 terms, so we do the a times c. It'll be -9x squared is the a times c, and then your b value on the bottom. And what we'll multiply to get the top and add to get the bottom is 9x and -1x. I'll do the grouping method this time. So 3x squared plus 9x minus x minus 3. And looking at the groups, my first group, my GCF would be 3x times x plus 3. And this would be -1 times x plus 3 to give me 3x minus 1 times x plus 3. And then you just solve to get your other roots. So 3x minus 1 equals 0, x plus 3 equals 0. You would add 1, then divide by 3 to get x equals 1 over 3, and subtract 3 to get x equals -3. Okay, so keep in mind that these roots, these are all the possible real roots that we could have. And so far we have been getting the numbers the same as what the real roots we predicted are. Okay, so in the next example, we're actually going to end up with an imaginary number for our roots. So that will not show up with our possible real roots, and we do have to factor this to find those imaginary roots. So this one, we don't really have an option to factor. Okay, so here's our P, and here's our Q, and thinking of our factors. Okay, so factors of 12, well, 1 goes into 12, 2, 3, 4, 6, and 12. Those are all my factors of 12. Okay, 7, 8, 9, those numbers don't go in, but 1, 2, 3, 4, 6, and 12, all those factors go in. And for my factors of 3, I have 1 and 3. So I'm going to do fractions of all these numbers over 1, and then do another set of fractions of all these numbers over 3. So a lot of these fractions, you want to reduce them because they'll come out to be nice whole numbers. So we have plus or minus. So everything over 1, they stay as whole numbers. So it'll be 1 over 1 plus or minus 2 over 1 plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, and plus or minus 12 over 1. Next we have over 3, so plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 3 over 3 is 1. We already have that listed. Plus or minus 4 over 3, plus or minus 6 over 3. 6 divided by 3 is 2, so we already have that. And then plus or minus 12 over 3 is 4, so we already have that. So this is going to be all of our possible roots. Okay, so I'm going to start with 1, because I always start with 1, and then try 3, 9, 4, and 12. 3 times 1 is 3. We have 12 times 1 is 12. 16. Okay, so this definitely isn't going to work out. So 1 is not going to be one of my roots. And we can keep going with this, and you'll see that negative 3 is going to work. 3, 9, 4, and 12. So negative 3 is actually going to work for this. Bring down the 3, negative 9 to have 0. Bring down the 4. 4 times negative 3 is negative 12. And those add up to be 0. So this negative 3 is going to be one of our factors. So negative 3, x equals negative 3 is one of our answers. So don't forget to make note of that. And what we have here, our highest exponent from the original is 3. Highest exponent is 3, so this highest exponent is 2. So this is 3x squared plus 0x plus 4. I don't need to include the 0x. 0 just equals a 0. So just to rewrite this, I'll have 3x squared plus 4 as one of the factors. So if we look at this, thinking about the ways we can factor two terms, we don't have a difference of squares. 3 is not a perfect square, and this isn't a difference, it's addition. And we don't have sum or difference of cubes because this is not a perfect cube. So the way we're going to solve is by using square roots. So I'll first subtract 4. So remember, solving with square roots, we're trying to get just x squared by itself. So I would divide out the 3. And now that I have x squared alone, I can use the square root. Okay, so this will be x is equal to square root of negative 4. And what is the square root of negative 4? It will be plus or minus 2i over root 3. And we can't leave our answer with root 3 in the bottom, so we just multiply by root 3 to get plus or minus 2i root 3 over 3. And our original had an exponent of 3, and we have 1, 2, 3 answers. Okay, this one is also a little bit different from the first two. Okay, looking at our factors of P and Q. 15 factors of 15 would be 1, 2 doesn't go in, 3 goes into 15, 5, and 15. So 1, 3, 5, and 15. Factors of 2 are 1 and 2. So our possible roots, I always do fractions over 1 first. So it would be plus or minus 1, 3, 5, and 15. And then fractions over 2. So we have 1/2, 3 halves. Oops, I forgot my plus and minus. 5 halves, and 15 halves. Okay, so going through these, you'll have to test them out to see which ones will work, and you'll end up finding that negative 3 over 2 will be the root that works. So don't be afraid of the fractions, they will work sometimes. We have 2, 9, 19, and 15 for a synthetic division. Bring down the 2. When I multiply 2 by 3 halves, You can view it as like the 2's cancel. So I'm just left with -3. 9 minus 3 is 6. And then 2 goes into 6 3 times. 3 times -3 is -9. And then 2 goes into 10 5 times -3 is -15. So if you have troubles with the fractions, you can always use the calculator, but it's faster if you understand how to do that in your head. So we have to include one of our answers being -3/2. So if x equals -3/2, my highest exponent was 3 with the beginning part. So this is going to be 2x squared plus 6x plus 10. So if we look here and we want to factor it, remember for factoring, we always want to take out the GCF first. So looking at this, I can see I could divide 2 out of each of these. And then I have 3 terms, so generally I would do the a times c. But when I think of factors of 5 that would add up to 3, there aren't any. There's only 1 in 5 for factors of 5, and none of them will add up to 3. So when your highest exponent is 2, that means we'll have to use the quadratic formula to find our roots. So here our a value is 1, b is 3, c is 5, and we plug it into the formula. So it's negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So inside the radical, we should end up with -11. And we can't simplify that root anymore, except we can't leave the negative in there. So we'll end up with x equals -3 plus or minus I root 11 over 2. So we need 3 answers, and 1, 2, 3. So we could have actually used the quadratic formula on this one and the first two also, if you end up with just x squared as your highest exponent. Actually, we couldn't use it on this one because we have, or no, we could. Sorry. So you could use the quadratic formula on all these, or you could factor them out. I like factoring. I think it's a little easier, but feel free to use that formula when your highest exponent is 2.